My name is Dr. Ashish Dixit. I am an associate professor in a computer science engineering department in AKGEC Engineering College. So today topic is related to matrix and multiplication, and subject is a design analysis of algorithm. So this topic is also considered in dynamic programming concept. So here we will discuss about what's the dynamic programming. A dynamic programming is a method for solving certain kind of the problems, and the dynamic problem can be applied when the solution of a problem includes solution to a subproblems. So a dynamic problem solves each subproblems one and store the result in a table so that it can be rapidly retrieved if needed again and again, and in the end we will get the solution of the whole problems. So a dynamic programming is a meta technique, not an algorithm like divide and conquer concept, used when a problem breaks down into the recurring small subproblems. So here you will mention some properties of the dynamic problems. A simple subproblems and an optimal structure of the problems, and a subproblems overlap, means we are facing these types of properties. Okay, so here we will discuss the simple subproblems. We should be able to break the original problem to smaller subproblems and that have a same structures. And next thing, a optimal substructure of the problems. The solution to the problem must be composition of the subproblem solution, and a subproblems overlap. Optimal subproblems to unrelated problems can contain a subproblems in a common. So a programming may be good for these problems like optimization problems and have a many possible solution, each a value associated with it, and if you want to a solution, then problem will be optimal, minimum or a maximum concept. So here we will discuss about the one examples of the matrix and multiplication. So in a matrix and multiplication, we are categorize the structure of the optimal solution, then recursively define the value of an optimal solution and compute the value of an optimal solution in a bottom fashion, and construct the optimal solution for the entire problem from the computed values of the smaller problem. Okay, so here we will take one examples. Our example is a dynamic programming is an algorithm that solves the problems matrix and multiplication. We are given a sequence chain A1, A2. These are A1, A2, A3, AN. Here we have a 1 to n matrices to be multiplied. We wish to compute the product. Okay, what is the process of the multiplication? Suppose that we have a 4 matrices A1, A2, A3 and A4. Then these are the way of the solution. Then for examples, if the chain matrices is A1, A2, A3, A4, then we can fully parenthesize problem A1, A2, A3, A4 in 5 distinct way. First A1, then bracket A2 and A3, A4. Then second A1, then A2, A3, then A4. And a third A1, A2 multiply A3, A4. Then fourth A1, A2, A3 and A4. Then fifth A1, A2, A3 and A4. So here the concept of the matrix and multiplication, it's a simple matrix and multiplication. If row and column does not equals to, then incompatible dimensions. Always kept in mind, if a matrix have not equal row and column, then it can't be multiply. Means matrix will be symmetric. Okay. So here, if a matrix A column does not equals to matrix B row, then error incompatible dimensions. If we will consider an else part, A row multiply B column matrix, then I is equals to 1 to A dot row, then J 1 to B column, then initialization of the Cij is equals to 0 and taken a for loop, and here multiply the concept Cij equals to Cij plus Aik matrix multiplication Bkj. These are the simple matrix chain multiplication. Next, again we will consider matrix chain multiplication in a straightforward matrix multiplication. Suppose that we have a n number of matrices, and here given one examples. Consider 3 matrices A1, A2, 3 matrices A1, the size of 10 multiplied 100, A2 size of 100 multiplied 10, and A3 size of 5 multiplied 50. Okay. So there are 2 ways to compute the product A1, A2, A3. Means A1, A2, A3 combined, then A3, then 10 multiply 100 multiply 5 plus 10 comma 5 plus 50. Okay. The value is 7500. Again A1, A2, A3, then we will get the information A2, A3, then 10 into 100 plus 50 plus 100 minus a multiply 5 multiply 50, then 75,000. Okay. Then what is the optimal solution? This is the optimal solution. Let's say structure of an optimal parenthesization. Suppose that a matrix Mij be a minimum number of the scalar multiplication. Compute Aij. Then the problem is to find the M1 to n. Then here the value of Mij is equals to, so here we will write down the Mi comma j if I is equals to j, row is equals to column have a same value, then we will get the 0 result. And if I is less than j, then what will be happen? Then minimum of I is less than or equals to j and less than or equals to j, then the value will be Mi comma k plus Mk plus 1 comma j plus Pi minus 1 comma Pk comma Pj. Okay. These are the values. Main formula. It's a main formula. Here to construct an optimal solution by this formula and define a, after this we will define a Sij, means parenthesization matrix. Okay. We also called the Si comma j matrix. Next, here this is the algorithm of the matrix chain multiplication. Here a matrix chain multiplication. So suppose that in a starting way we have the length of the matrix P, then P dot length minus 1 is put into the n, then let m 1 to n and S parenthesization matrix 1 to n minus 1 and 2 to n be in row tables. Okay. So here we will apply the for loop I is equals to 1 to n. Then if I comma j is equals to, then we will put the value of the m I comma I is equals to 0. Again we will take the another loop L, and it's running from a 2 to n condition. L is the chain length. Then here I bar 1 to n minus L plus 1, and again we will take a next loop j is equals to I plus L minus 1. In a mij in a starting way, in a all mij we will have the infinity, because why we will take the infinity? Here if any value will be get, then we will compare by the infinity and find the minimum value. Then suppose that we will get the 800, and then again we will compare with the mij infinity. The obvious say 800 is less than infinity. That is why we will consider a minimum value. Again k is equals to 1 to j minus 1, and here we will apply the formula mij. Q is equals to mik plus m k plus 1 comma j and pi minus 1 comma multiply pk multiply pj, and whole value we will consider in a q, and again we will consider in a q. Then we will compare of the q value by the mij value. Here mij value is infinity. Then again I already said that if a minimum value, if we have any value, then we will compare through the infinity, and obvious given value will be obvious less than comparison of infinity, and that's why the minimum value we will consider. So mij, we will put the value of q in a mij. Okay. Then again through the k we will consider the value of the parenthesis matrix. Then after we will get the return value m and s, means a matrix value and a parenthesization value. Again we will consider a one example, then definitely we will sure that it's a correct problem of the dynamic problem. So here it's one example. M and S is a table computed by the matrician multiplication. Here n is equals to 6 and the following matrix is the dimensions. These are a matrix and these are a dimensions. Here this is a A1 matrix and this is the dimensions of A1. A2 matrix, these are the dimensions of the A2. Here A3, these are a dimension of the A3. A4, the dimensions. A5, then dimensions. A6, then dimensions. Okay. So firstly we will draw a matrix. These are the values 1, 2, 3, 4, 5, 6, the length of the matrix, and here 1, 2, 3, 4, 5, 6 matrix. Okay. Again we will consider where I and j value are same, then we will consider a 0. These are a 0. Okay. Then after in a below less than 0 we will consider a blank. These, and after these it will be removed. These are a 1, 2, 3, 4, 5 and 6, and these are a j. Here we will again consider for I, here I, and here j. 1, 2, 3, 4, 5 and 6. Okay, here 1, 2, 3, 4, 5 and 6. These are I, and again it will be rotate by this. Then again concept for I barabar 1 and j barabar 2. Here I is equals to 1 and j is equals to 2, and put the infinity right now. Okay, then again we will calculate the value m1 comma 2. Here the value we will calculate the value m1 comma 2. Right now we have an infinity, but through the formula we will apply the here. These are the value. If j equals to 2, 1, 2, 3, 4, 5 and 6. Then again m1 comma 2. Then for k barabar 1, the k is equals to 1. Then again the value will be put here. Q is equals to m I comma k plus m k plus 1 comma j plus pi minus 1 pk and pj. Then find the value. m1 comma 1 plus m2 comma 2 plus 30, then 35, then 15. Okay, then here m1 comma 1 value 0, m2 comma 2 value 0, and this value is 15750. Then if we compare the 15750 by the infinity, then obviously it's will be minimum. Then here we will consider the minimum value 15750. Got it? Next, again we will consider the value 2 comma 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the I and this is the j. Again we will get the value m2 comma 3, because m2 comma 3. Okay, these are value of the m2 comma 3. What is the value? Then for k equals to 2, then again value is m2 comma 2 plus m3 comma 3 plus p1 p2 p3. What is the value? 0 0. Then again p1 p2 p3, we will get the value 2625. So here the value is 2625. Okay, means that these are the examples. Again we will m2 comma 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. m2 comma 5. These are how will we fetch the these value 2 comma 5. Okay, then again we will consider the examples this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the j and this is the I. Okay, then we will get the value m2 comma 5, m2 comma 4, then m2 comma 6. These way we will get the solution. Okay, what is the formula? Because m2 comma 5 we will consider, then first way m2 comma 2, m3 comma 5, p1 p2 p5, then value 25 0 25, 35 multiply 5 5 and 20, then we will get the 13,000. Again m2 comma 3, then 2 comma 3 plus m4 comma 5, p1 p3 p5, 2625, 100, then this value will be 7125. Again M2 comma 4, M5 comma 5, P1, P4, P5, 4, 3, 7, 5 value, then 0, then this, and we will get the 11, 3, 7, 5. What is the minimal concept, optimal concept? Optimal concept is 7, 2, 5 is a minimum value in comparison of these three. Then here 7, 1, 2, 5. Then after we will get the result M2 comma 5, then we will consider 7, 1, 2, 5. Okay. So after this we will left rotate of this way. Okay. Then again we will consider this. This is the particular way. These are I and these are J. Here 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4, 5, 6. These are the matrix. These are the zeroth of them. These are diagonal values. Okay. And similar way we will get the parenthesization, means at which k it will be find the value. Then here 3, 3, 3, 3, 3, 3, then 1, 3, 5, 3, 5, then 1, 2, 3, 4, 5. Okay. These are the parenthesization matrix. This is the concept of the optimal parental multiplication values. And thank you very much.